Alrighty, we're back. Welcome to the Garage Lab. So excited to have you here again. Last time we were together, we were discussing Mosley and Mendeleev and the development of the periodic table. What we're going to do here today and over the next couple of our digital chit-chats is discuss how we can use the periodic table as a useful tool. It is arguably one of the most elegant and useful and well-designed tools in scientific history. It is a pinnacle of human achievement. No big deal. Yeah, that's where we're basically moving forward from there. So looking at the periodic table, I'm going to pause you at this point in time, go into that mega packet that I sent home with you last week. In it, you'll find two periodic tables that look something like this. Right, they're blank periodic tables, the periodic table of the element. You need one of those. Choose your least favorite one. What you're going to do here is basically start this annotation process of your periodic table. There's a lot of information that we can unpack from this guy. That we're going to include here. So you're going to do like a trial run on this first one, and then we'll make a nicer one on that other sheet that I gave you. So choose your least favorite, maybe like one that got sprinkled, it doesn't matter. But choose one of your periodic tables. That's what we're going to be using here today. All right, let's begin. So here is where we're going to start ourselves. Again, same deal as last time. If you are someone who would rather go through all the way and then fill in your notes at the end, totally fine. Again, today's notes are about the same much as we did like last time. It's not a whole lot of stuff. If you'd rather pause me along the way, choice is totally yours. I do not care in the slightest. Today we're talking about metals and other stuff. What's cool about our periodic table is all 118 elements that we've discovered so far fall into one of three categories. Any guesses as to what those three categories are? You're right, they're metals, nonmetals, and metalloids, which is pretty darn cool. And it's gonna be an easy way for us to classify our elements right off the bat. So that's where we're gonna start here today. So first things first, what I'd like you to do is take this periodic table that you have, your least favorite one, the one that's like, at this point, empty. And what we're gonna do first is add this big old staircase to it. It's this red line here. Yours doesn't already have it. I have it here on the slide. It's going to be 1, 2, 3, 4, 5, 6, 7. Let's end it here. Don't do this last L shape for me because I think that is a little bit excessive. So you're going to take, I used a big like red Crayola marker because I like it and it's what I had. And we're going to draw this nice big old stair step for ourselves. And this stair step is exactly what it looks like, right? It's a stair step. Sometimes it's called the ladder of your periodic table. Basically what's going to be is a landmark for us. We're going to use it to determine the location of a lot of other elements on our periodic table. So at this point, hopefully your periodic table has a nice well-defined stair step. Tricky part here is making it well-defined without covering any important information, right? Like don't color over like the atomic masses or things like that. That'd be not useful. All right, once you got your stair step on, I need you to choose 3 of your favorite colors that are lighter in tone or hue, I guess. You want people to, again, see through whatever you're going to color. I'm using orange, green, and blue. What do you think we're going to use these 3 colors to denote? You're right, the 3 different things that we can classify elements as: metals, nonmetals, and metalloids. Choose your least favorite color. You're going to color the fewest of your elements in this color. I'm going to do orange. And let's make a key for ourselves. We're going to make our keys, we're going to color this in, and then we'll talk about what each of these different categories mean. But up here at the top, what I did is I drew like an orange squiggle. It's just like a square. And then next to it, I'm gonna put metalloid, probably in that same color. Just kidding, this colored pencil is terrible, so I'm gonna do it in pencil, because that's what I got. I'm gonna write metalloid here. So our metalloids are one type of element that we're gonna have. And what's gonna be convenient for us is we're not gonna have very many of them on our periodic table. Our metalloids are gonna live on the stair step. And there's going to be, how many of them are there? 1, 2, 3, 4, 5, 6, 7 of them that we're going to care about. So in your metalloid color, we're going to color in the following elements. We're going to color in boron up here at the top. B, that's atomic number 5. We're going to color in silicone, which is on the next step, atomic number 14. We're going to color in germanium, atomic number 32. It's right below silicone. We're going to color arsenic, atomic number 33, right next to germanium. We're going to color in antimony, atomic number 51, right underneath arsenic. We're going to color in tellurium, atomic number 52, right next to antimony. And then last but not least, we're going to color in polonium, atomic number 84. If you'll notice here, how many did we just color in? 1, 2, 3, 4, 5, 6, 7 of them. These 7 guys live on the stair step of your periodic table, right? Boron is this first one. Silicon and germanium directly border it. Arsenic and antimony, again, directly border it. Tellurium and polonium directly border that stair step. So that stair step is an important indicator for us. It's a landmark on our periodic table. It says, hey, here's where our metalloids live. And that's it. That's all we care about for those guys. Let's take your second favorite color. This is the one that you're going to be coloring more than you did for your metalloids, but not nearly as many for your metals. And again, let's make a key for ourselves. I did it up here. I'm going to say this green color. This is going to indicate for me all of my non-metals. For me, I think of non-metals, I think of like gases and like mysterious substances. And for me, that's a very green color. So up on my key, I'm going to color in green. I'm going to say non-metals, if I can spell it right. And our non-metals are going to live on the right-hand side of our periodic table. They're going to live to the right of that big old stair step. Everything that's not your non-metal or your metalloids. So it's going to start here. Carbon, nitrogen, oxygen, fluorine, this whole entire column. Acetine, tennessine, probably named for Tennessee. That's kind of cool. Colored in all of these guys here. So everything to the right of your stair step that's not a metalloid is going to be a non-metal, which makes sense for us, right? We look at some of these elements that we've just colored in. We're seeing things like oxygen. Is oxygen a metal? No, it's a non-metal. We look at things like chlorine and sulfur and bromine. Those are all non-metals. They're things that are typically not solids at room temperature sometimes, but we don't typically associate them as being metallic compounds. Last but not least, you're going to take your favorite color pencil color because you're going to color in whatever is left, which is most of your periodic table. In my key here up top, I'm going to give myself a nice little color. I'm going to say these guys, the rest are all going to be metals. And we're going to go ahead and color them all in. Before you do though, one important point. I left off a crucial element for us. Go back to your non-metal color for me. Go back to your periodic table. Hydrogen, this first guy here, is a non-metal. It's in a weird spot, but it's a non-metal. Sorry, I forgot him. Sorry, hydrogen. All the rest of your non-metals to the right of that stair step. Everything that's left now, we're going to color in with our metallic color. For me, I'm doing blue because that seems like a metal-y color, I think. So starting here, lithium, beryllium, these whole groups, this whole middle section of our periodic table, all the way over to our stair step. Aluminum is a metal. And we're also going to include these bottom 2 periods here beneath our periodic table. These guys are also all metals. You can do a nicer job coloring in. I'm not a very great colorer. But if we look at some of the ones we just colored in, it makes sense that these are our metals, right? Copper, zinc, nickel, let's see, aluminum, silver, gold. These are all things we traditionally associate with being metals. They're our metallic side of the periodic table. Everything to the left of that stair step, except for hydrogen, is going to fall into that metal category. If you can't see my coloring, because the light in here is poor because I'm in my garage, or you didn't hear what I said or anything like that, I have scanned a copy of a colored in periodic table that is posted on Google Classroom if you want to take a look at that guy before you begin the coloring process. I think that'd be super reasonable. We've divided our periodic table now into these 3 major categories, right? Our metals, our non-metals, and our metalloids. But what do these 3 different categories mean? What a great question. Thank you so much for bringing it up. Let's find out. So when we're talking about our metals, what we're traditionally talking about are things that are metallic. These are elements that tend to be solid at room temperature. They're shiny. They are ductile, which means that they can be pulled into wires. They're malleable, meaning if you hit them with a hammer, you can pound them into sheets. They're good conductors, meaning that they transmute electricity or heat. And they have what we're going to call them valence electrons. We haven't talked about them yet, but just include them in your notes right now. We'll get to them next week. But metals as a whole tend to have few valence electrons. So in your notes here, this is the piece that's going to actually end up in your notebook. You don't have to do it in like a cool table like this. whatever is convenient for you. But this is a summary of these characteristics that all of our metallic elements are going to have. So looking at our periodic table, things like copper and nickel and cobalt all tend to be, for the most part, shiny. They tend to be ductile. They tend to be malleable. They're good conductors. They're mostly solid at room temperatures, and they have few valence electrons. It's going to be important for us here that we can look at a periodic table and find some elements that fall into this metallic category. So you'll be able to look at a periodic table and say, ah, yes, lead, that's a metal. Ah, yes, zirconium is also a metal. We also want to be able to, based on an element's properties, determine what category it's going to fall into. If someone says, hey, we found this mysterious substance, it's a really good conductor of heat, it's a solid at room temperature, and it's really, really shiny, we want to be able to say, that sounds like a metal. Are you feeling okay? Good. This is so fun. Moving right along to the other side of our periodic table. So that right-hand side, those are the ones that I colored in green. These guys here are our nonmetals. And believe it or not, our nonmetals are the exact opposite of all of our metals. These guys are not solid at room temperature. In fact, most of them tend to be gases. They are not shiny. They are not ductile. They are not malleable. They do not have few valence electrons. Instead, they have a mostly full outer shell. So in our notes, we will tell ourselves here that our nonmetals are not shiny. They're not ductile. In fact, they're very, very brittle, meaning that they're not malleable. They're poor conductors of heat and electricity. They're mostly gases at room temperature, mostly full valence electron shells. And again, we want to be able to do the same thing that we can with our metals that we can with our nonmetals. Can we look at a periodic table? Can you find 5 nonmetals? Things like hydrogen, fluorine, oxygen, sulfur, chlorine. These are all going to be nonmetals on our periodic table. And again, the same story. If someone says, hey, sorry, my dog's right here. He says hello. If someone says, hey, we found this mysterious properties, we found this mysterious element, hang on 1 second. Just kidding. Buddy, come on, go. If someone says, hey, we found this mysterious element and it's not ductile, it's super brittle, it's got a lot of valence electrons, you want to be able to say, sounds like a nonmetal. Last but not least here, we hit this weird in-between category, which are those couple, I think we counted 7 different elements. Just a second, come on, buddy. Okay, back to our metalloids. So we counted 7 of them on our periodic table. These guys are weird kind of flex elements. They don't fall nicely into that metallic category. They don't fall nicely into that non-metal category. They're very much straddling the line physically on that stair step between your metals and your non-metals. These guys, for the most part, tend to be semiconductors, meaning they're like okay at conducting. Some of them are shiny. Some of them are very, very brittle. They have about a half-full outer shell. So in some ways, they're very similar to metals. Some ways, they're very similar to non-metals, but they're really just like this weird in-between mysterious group. So as a whole, we'll say that they are sometimes shiny, sometimes ductile, sometimes malleable, but like not really. They're mostly solids at room temperature. They're sometimes good conductors. They're hard to describe because as a whole, they're like. But a big takeaway for us here that we'll discuss in greater detail next week is this idea that they have a half-full valence electron shell, which makes them pretty special and like kind of cool. Yes, so we counted 7. I'm asking you to find 6 examples. Pop them in your notebook for me. Choose your favorite. I think that's gonna wrap us up here. We're gonna say that all of our elements fall into one of these 3 categories. They're either a metal, a metalloid, or a non-metal. Not so bad. Do a nice job coloring in just coloring for right now 1 of your periodic tables, color in your metals, your non-metals, your metalloids. Make sure you get that stair step in. We'll do the other periodic table together. Leave it blank for right now. But we're gonna end it right there. If you have any questions, I'm on Zoom, hop on there, give me a shout out and we'll be good to go. All right, and then that's it for us here today. See you soon.